Recording in progress.
Good afternoon, ladies and gentlemen. Happy half term. It's February, so that means, well, let's not even count how many weeks it is until the exam starts. So I'm live with some students who have registered for this webinar. So I'm casting live to them. I'm live on YouTube. I'm live on TikTok. Basically, I'm going to try and keep an eye on everything. But ostensibly, in the main, I will be chatting to the students who have registered for this webinar. So with that in mind, if you're in the webinar room with me now, just say hello in the chat. Just let me know what year you're in. Let me know what exam board you are. Basically, just to say hi and who you are. And we're going to be talking basically strategies for A-level chemistry. Okay, I'll be honest with you, I've got nothing planned. I really want you guys to kind of lead this. I want to show off what Chemistry Coach can do for you as well. So we'll be doing a bit of that. So obviously, any questions about Chemistry Coach, and you can ask away on there too, okay? So hello, I won't mention names, guys, but hello. So you're a research student doing OCR-A. Welcome, welcome, welcome. OCR's tough, right? I'll tell you why OCR's tough is because they really mix the topics of the questions, don't they? So, you can have like a 18-mark question, multiple sections to it, and go through 4 or 5 different topics. So I feel your pain in OCR. Who's everyone else that's kind of joining me today? Like, what are you doing? And I'll tell you what, maybe put some pain points in there. Okay, so let me know your situation. Let me know some pain points. Now, actually, since you've mentioned you're a research student, if you are a research student out there, okay, the most important thing you can do is past papers. That should be your go-to, okay, because you've learned all the content. Obviously, if there's anything glaring that you don't understand, yes, work on that. But obviously, this whole year is revision for you if you're a research student, okay? And what you want to do is obviously learning from your mistakes. Anyone can get an A star in A-level chemistry. It's just about making sure you understand the topics. You can't just learn things parrot fashion. Classic revision doesn't necessarily help you understand. Application helps you understand. So everything you should be doing for A-level chemistry, especially if you're a research student, is application, 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 because A-level chemistry papers are full of problem-solving questions. So you need to be able to use your knowledge and skills, very, very importantly, skills, in order to get through those questions, okay? So a question on TikTok: is it worth doing old spec past papers once you've done all the new spec ones? 2 points on that, my friend. Number one, let's say yes, it is worth doing old spec papers, but you do need to have insight into the spec to go, actually, what don't they contain, what do they contain that you don't need to know, okay? So there may be things missing that you do need to know, there may be things in there that you don't need to know. One thing that comes to mind, for example, is Arrhenius equation. So none of the old spec for any of the exam boards have Arrhenius equation in there, so you're not going to get any more practice there. I tell you what, rules for doing old spec: be aware of the spec, okay? The question style is slightly different as well. Second point I want to make is that new spec papers, once you've done one, it is not dead to you, okay? It is not like, oh, that's spoiled now, I can never do that again. If you did one today and then did the same paper in 3 months' time just before the exams, you wouldn't know all the answers, okay? So do not fool yourself. Cycle them round. Start on 2017 as your first one for A-level, and then work your way through. Once you got to the end, go back and start again, okay? Because the questions in A-level chemistry are similar. That is a fact from year to year. So that's super important, right? New spec papers are not dead to you. Old spec papers, okay, proceed with caution, but they're pretty good, okay? The other thing I'll say is doing questions from other exam boards. Now, if you're doing OCR, for example, and you come across an AQA pack that's for titrations, you're absolutely fine, okay? Just go with it, all right? So ostensibly, in the main, if you're looking at, let's say, calculation-based stuff, okay, in the main, you're okay doing other exam board papers, okay, other exam board papers. And that's the reason why, is because the Arrhenius is the Arrhenius, Hess's law is Hess's law, a Born-Haber cycle is a Born-Haber cycle, buffer calcs are buffer calcs, So absolutely you're okay doing those sorts of things. The main differences in the exam board lie within knowledge, and that is organic chemistry, transition metals. In the main, okay? There are other differences, of course. So, I teach all of them, so I know all the major differences and the minor ones, to be fair, like the wording they like to use. But just be careful, okay? Just be careful. So, as I say, I'm going to be led by you guys. So, whoever else we've got in this live here, then just make sure you say hello. If you've got any requests for things for me to go through, then absolutely just I am your dancing chemistry monkey this afternoon, ladies and gentlemen. Okay. So, like I said, requests in the chat. If none come in on the webinar, then I'm just going to go to social. So, feel free if you're in the socials, then just make sure that make sure you get involved as well, folks. Okay, I'm quite happy to answer questions if you're on the socials and basically just teach you whatever you want to be taught. So, with what you should be doing now, okay, let's just talk generally. If no one's going to request anything, I'll jump into something in a minute. Exams start now, okay? Exams start now. Random question, do I know how to wiggle my ears? I think that's somebody I know. I don't know who account that is, but that is definitely somebody I know. Yes, I can. And I'm a dancing chemistry monkey, but I'm not that much of a dancing chemistry monkey, okay? So what should you be doing now, okay? AS students, okay? If we have any AS kind of resitters or anything like that, WJ, you should absolutely start revising now. But if you're an A-level student, your exams are a little later, you should absolutely be revising now, okay? Now, I would wager that you have finished one complete unit. You must be testing yourself on that unit from now, okay? Don't just think, oh, I've done that. That's kind of parked. I'll put that on the shelf for now. I'll get through the next unit and then I'll come back to that and revise that nearer the exams. I mean, that's procrastination. Okay, there's so much stuff in there in terms of the calculations. I take it you've probably finished I take it you've probably finished all the physical chemistry side of things, maybe even the inorganic, and you're into organic chemistry now. That tends to be the way teachers kind of do that. Okay. Balin, you can absolutely request topics. That's what I've been asking. If you want me to kind of go through something, that's what I'm here to do. Okay, so just a live, basically to give general advice, show you how Chemistry Coach works and stuff like that. So revision must start now for any unit you've already completed. Okay, now A-level students, I would even definitely, and you should, I gave this advice out kind of probably in November, December, do paper 1 and paper 2 AS as well. Okay, because especially I would say paper 1. The reason being, the most common things that kind of come up in A-level papers that are AS topics are basically, I would say, in the main bonding. Okay, there's very little bonding in A-level chemistry. When you think about it, I suppose the only bonding you really come across is looking at the structure and bonding in benzene. That's it. Okay, there's nothing else really going on there apart from obviously transition metals where you've got coordinate bonds with the ligands, but you don't talk about bonding and intermolecular forces and the link to melting and boiling points and things. Of course, they love that. Okay. Oh, wow, okay. So I got a request for topics: thermodynamics, electropotentials, electrochemical cells, acids and bases. Okay, so yeah, absolutely. We can cover all those, all the physical side of things, and give you my best advice as far as those topics are concerned. So we're focusing on A-level chemistry today. So let's have a look then, thermodynamics. So what I'm going to do is I'm going to share my screen in a sec. And let's have a look at physical chemistry. Now, I've got the books, okay? These are the books that I've produced for A-level chemistry, and I'll just show you guys now. So these are the books that I've produced for A-level chemistry. This is AQA, for example. Now, if you're OCR or EdXL even, or WJEC, everything I'm about to tell you about thermodynamics and things to watch out for are absolutely relevant. There are slight differences, but like I said, I'm going to give you my best advice in terms of like the stuff that you need to be able to, that you need to know, and the stuff you need to be able to do. Okay. So these books, for example, in OCR, it's module 1, module 2, module 3, module 4, so on and so forth. In AQA, it's physical chemistry, inorganic chemistry, and organic chemistry. So I'll give you links to the book. I tried to download the notes yesterday to email me, but it didn't let me. What happened there, Balin? Did you not get the email? Did the link not work? Just let me know in the chat and I can fix that, okay? So today I will give away the notes. Absolutely happy to do that. I'll give you a link so you can download whatever exam board you are. And there's also a kind of cheeky little discount code. And by the end of this, after this live, anyone that's been here with me in this live, that you registered, I will be giving away a subscription. Okay, so just completely at random. Anybody that's been live with me chatting away in the webinar, not online on socials. Okay, you needed to have registered. So let's start with thermodynamics. Okay, no worries, Ballum. It worked for everyone else, so maybe try again, but just double check what email you put in there, okay? Because it's worked for about 10 other people the other day, and they downloaded the notes, no problem at all. They got the email, so just double check that, okay? So I know it's working, so just double check that. Okay, so let's break things down. Now, every topic in A-level chemistry lends itself to being split into two areas, okay? And this gives your revision some structure. Let's say thermodynamics, okay? Let's break it down, and every topic you can do this with, what I need to know and what I need to be able to do. So stuff you need to just recall, okay? Facts, definitions, okay? Observations, colors of tests, stuff like that. And on the other side of things, you need to be able to do what, okay? So calculate X, be able to identify Y, so on and so forth, all right? So let's break this down in terms of lattice enthalpy, in terms of thermodynamics, okay? So first of all, we have got our knowledge of lattice enthalpy. So what is lattice enthalpy? This is very much recall, being able to write the definition for lattice enthalpy. So the enthalpy change where 1 mole of an ionic substance dissociates fully into gaseous ions, and of course the opposite as well. So we've got lattice association and lattice dissociation. Obviously hints here that dissociation is always positive. Okay, now the reason for that is because we're pulling two things apart that have been attracted to each other, okay? So we're pulling things apart there. So anytime you're breaking a bond or an intermolecular force or an electrostatic attraction, anything from ionization energies, taking an electron away, to separating water molecules, breaking the hydrogen bonding, all of those are endothermic. So if you're ever unsure whether a process is exo or endo, just look at the equation, look at what's happening and ask yourself, are you pulling two things apart that would normally be attracted to each other? Yes, Alicia, bendo, mexo, absolutely. This is so important. Breaking bonds is endothermic, making bonds is exothermic, okay? So bendo, mexo is a little tip there for you. I think you probably heard it before. And of course, when things come together that form an electrostatic attraction, a bond, an intermolecular force, that's where energy is released, so it's a negative delta H. So you've got your lattice enthalpies, okay? I'm going to talk about Born-Haber cycles in a second, but look at this, okay? You need to know these, okay? So for example, in the list of things you need to know for thermochemistry, it is the symbols and the names and the definitions of each of these different enthalpy changes that are involved not only in Born-Haber cycles, but of course enthalpy of solution as well, and I'll show you those in a second, okay? So knowing these definitions, why are these definitions so important? Well, if you look, let's take a new one, let's say atomization, okay? This is new for A-level, you didn't learn this at GCSE, at year 12. So the enthalpy change where 1 mole of an element in its standard state is atomized to produce 1 mole of gaseous atoms. Now, the reason these definitions are so important is because it's basically the equation in words. The definition is a description of what's happening in the equation, where 1 mole of an element, okay, so no number in front, produces 1 mole of gaseous atoms. And that goes to explain why this is half Cl2 to Cl, because we only need to make 1 mole of gaseous atoms. If I wrote Cl2 goes to 2Cl, that is not the equation for atomization because we're making 2 of them. Okay, so it doesn't fit the definition. So knowing these definitions, proper flashcard territory, okay, testing yourselves on these. Chemistry Coach has got inbuilt flashcards, digital flashcards you can use. All you need to do is ask it. So firmly under the column of things you need to know, definitions for delta H. Now you've got to just parrot fashion learn them. It's not beyond the exam boards to ask you for these as a 1 or 2 mark question. Now what's also handy is the sign. Okay, so delta H formations can be positive or negative. Atomization is always positive. Why? Because we're breaking electrostatic attractions, we're breaking bonds. Bond enthalpy is breaking bonds. Ionization energy is pulling an electron away from a positive nucleus, so that's always positive. Electron affinity can be positive or negative. First ones are always negative. Second electron affinity is always positive, okay? And then lattice association here, always negative. Of course, the opposite is positive. Now, added to those definitions, let's just skip on through for a second. Enthalpy of solution. So you've got a few more here. Delta H sol, again, the same applies, okay? Delta H solution is a balance between 2 other delta H's, okay? So delta H solution, the enthalpy change when 1 mole of a solid ionic substance is dissolved in water. How do we calculate it? Well, we calculate it using, where is it? This, okay? So delta H solution equals the lattice dissociation, always positive, plus the sum of the enthalpies of hydration, always negative. So it's very much a balance between these two. If this is always positive and these are always negative, the overall enthalpy change is the enthalpy of solution. Now, what's the upshot? Well, if it's negative, it's highly likely that that salt is soluble in water, okay? If you have a positive delta H solution, it's highly likely that it's not soluble. We can't say with certainty because there's other things like entropy and stuff we have to take into account. But just think of this as a balance between 2 things. It's a really simple thing to do. Obviously, they ask you to rearrange this sometimes in the exam, most of the time in the exam. So again, just being aware of those delta H's and their definitions, and that's the calculation. Knowing that, okay, a delta H formation could be positive or negative, for example. So having those in your mind. Now, in terms of Born-Haber cycles, I'll give you a general piece of advice. The typical things they ask, here's like a typical Born-Haber. The typical things that they ask in the exams, you need to be prepared to do all of these. 1, label the delta H's. You have to excuse me because since the iPad update, it just stops writing on here for some reason. You have to know these, okay? You have to be able to label these. How do you do that? Well, it's a game of spot the difference between these different symbols, okay, between these different species. So you have to look at the difference and go, what's happened here? And you can see here that potassium has been ionized, okay? So this is the first ionization energy of potassium. So knowing the definition allows you to know the equations, which enables you to do this. So this is something you have to be able to do, okay? This is, it's under that list. Of course, they could ask you to write the species on here. I'm sure you've seen Born-Haber cycles like that where you need to complete them. That's the same. You need to be able to look at this and go, okay, well, what's going to be the difference between here and here? Okay, think of every one of these jumps like a new equation. Okay, we're doing something to each level, and just, whether it's atomizing, ionizing, or electron affinity. Now, the other point I can make, the other kind of top tip I can give you is that when you look at any Born-Haber cycle, this side, okay, let's change the color out, make it stand out. Ooh, I've clicked something weird, but yeah, this side must equal, and I know it's not to scale, but it doesn't matter, must equal this side, okay? No worries, Alicia. So those two, okay, and people who know me will know that, I'm not like a maths guy, I'm all about finding the simplest, most reliable method to do any calculation in chemistry. So this side on the left must equal the sum of those changes on the right, okay? So for me, let's say if they asked you to calculate the delta H electron affinity of chlorine, okay? What I would do is I'd invert this one, okay, to make that negative or positive or whatever it might be. You invert the sign on that when you invert the arrow. You just add all of those up. Then you subtract, obviously, this part here, and it will leave you with this this value. Okay, so it's a really simplistic view of working with values in Born-Haber cycles, but if you just look at it that way, then it does kind of help really in terms of the context of the question. It comes with a caveat though. If you do this, your answer is always going to come out positive, okay? But of course, that's not always true. Sometimes it is a positive value. Let's say if you were calculating this, but if you look at it and the arrow's going down, it's an exothermic process, so that means it's going to be a negative answer. It doesn't matter how you get there, okay, as long as you get the right answer, but this is a very reliable way of doing so, okay? Or you could do equals to the 2 on the right, right? Yeah, that's exactly what I'm saying, Balin. You're saying the same thing, just a different way, okay? So just be aware, this is always going to give you a positive answer. You just need to then, it's going to give you the numerically correct answer, if you like. It's just we need to just stop and think about the sign. And we're used to doing that because in calorimetry, using Q equals MC delta T, then delta H is Q over N, which you'll be very familiar with, which is another thing that does come up in A-level papers. You have to just, once you've calculated your delta H, you need to go back and look at the temperature change and decide, is this a positive or a negative enthalpy change, okay? If you need to go now, then the recording of this will be sent to you if you've registered for this. So yeah, no worries. Well, you go do what you need to do, okay? But thank you for coming. Thank you very much for coming. So calculations. So perfect ionic model, not everyone needs to do. So keep it relevant for everybody. Let's list this, okay? Things you need to know, okay, for thermodynamics, for any exam board. Know all your delta H's. Use flashcards to learn them, okay? The definitions, a typical equation, how to write the equation for it. You need to know the typical equation for it, and you need to know what's the sign and why, okay? So, some of them are positive or negative, but, you've got a lot of bankers in here that you can be like, it's always positive, always negative, okay? So those are the things you need to know. Obviously, your expression as well to calculate delta H solution, okay? You need to know that expression. Now, that's it in terms of what you need to know. That's how far classic revision is going to get you. In order to improve your exam grade, you need to be really working on the things as well that you need to do, okay? Now, what do we need to do for thermodynamics? Well, we need to be able to write equations for each of these delta Fs. So knowing the equation, okay, like a typical one, but then of course you'll need to adapt it for the substance they give you in the exam, okay? So being able to write equations for the different delta H's, you need to be able to do that. You need to be able to complete a Born-Haber cycle, okay, by filling in the delta H's or filling in the symbols, okay, on each of the lines, okay. So you need to be able to do that and to game a spot the difference. Of course, the other thing you need to do is to be able to calculate any missing value in a Born-Haber cycle, okay, any missing value in a Born-Haber cycle. And lastly, what you'll need to be able to do, generally speaking, there are little differences between the exam boards on top of this as well, but the other major thing you need to do for all exam boards is be able to calculate delta H solution, okay, delta H solution, and, be able to rearrange this expression as well, okay? Are they going to ask you to find delta H solution? No, of course they're not. They're going to ask you to find one of the delta H hydrations. Of course they are. They're going to mix it up, right? So, the last thing I'll say actually about Born-Haber cycles is that there are only 4 types. Recognize your 4 types. It's only ever going to be between a group 1 and a group 7, a group 1 and a group 6, or a group 2 and a group 7, and a group 2 and a group 6. Okay, so there's 4 different flavors, if you like, of Born-Haber cycles which you can get stuck into. All right. So what I've got is something set up that I can show you basically just to help you with exam practice. Now, I had a question the other day that a student was asking me, like, can I, what was the student asking me? I've completely forgotten now. I've lost my train of thought. This is what happens with Rich. So a student asked me, like, should I do topic questions or questions by topic? So get a pack maybe from somewhere and do questions by topic. The answer is yes, but not just before the exam. Okay, you're way beyond that before getting to the exam. That's the sort of that's the sort of shit you should be doing as you go along. Okay, that's the sort of stuff you should be doing as you go through the year. When you finish a topic, right, boom, I'm going to just do some questions, make sure I understand it. Okay, maybe not even at the end of each topic, just kind of almost at the end of each week. You know, you need to be asking yourself, like, do I understand what I've learned this week? Yeah, I know we're all tired. We're all kind of like, you know what, I've earned my weekend. I'm just gonna chill. I'm gonna have some rest, and that's fine. But pick a time where you've got maybe free period in college. It doesn't have to be at the end of the week. Just to go, right, what did I do last week? Do I understand everything that I got taught last week? Okay, and just asking that simple question at the end of the week, you think, actually, no, I don't. I didn't. Like one of my students might be thinking, I have no idea what Rich was on about yesterday. So what are you going to do about it? Okay, well, you can go back to your teacher and ask. That's what they're there for. Okay, that's what I'm there for my students. But you know, you need to have the confidence to go, I don't know this. I don't understand this. What am I going to do about it? No one's going to do anything about it for you, okay? You know, it's your A level at the end of the day, okay? So you need to be asking yourself these questions. So please do use and utilize question packs that, okay, on a certain topic, but that's the sort of stuff you should be doing as you go along. When you get to this end of the year, okay, for any topics that you've completed, just before the exams, you shouldn't be doing that. Okay, you should be kind of doing full past papers. Okay, if you've covered all the topics for a unit, like I say, probably maybe unit 1 if you're AS, unit 3 if you're year 2, maybe module 4, 1, 2, 3, 5, module 5, sorry, if you're OCR, etc., etc., etc. So you really should be doing full past papers on that now. Okay, now the question is, like the question before, can I use old spec papers? Can I use other exam board papers? Like, where do I get questions from? Because, you know, the best students are like, nom, just kind of eating up the past paper questions and stuff. And you're always worried you're going to run out. Not with Chemistry Coach, okay? This is why I am convinced that this is probably the most powerful revision tool that's basically ever existed. Especially for A-level chemistry, I could even argue it for any science subject. Okay, I don't go beyond science like history and humanities and all that sort of stuff. But let me show you. So I'm just going to go to here. So this is the AQA A-level chemistry coach, and actually, let me just. There's been a question on TikTok. So what type of 6 markers do OCR-A usually ask in relation to transition metals? Now, I haven't got the OCR. There is an OCR one. Okay, if you sign up, you can access the OCR one. This is the AQA one. I'm going to ask it this exactly the same question. Okay, so I'm literally going to ask that. I'm not going to change anything. Okay, so I'll put the mic on. What type of 6 markers do AQA usually ask in relation to transition metals? All right, so that's a question that someone's posted on TikTok. I'm just asking it to prove that Chemistry Coach can actually do that. Okay, so great question. Looking at AQA past papers, here are the main types of 6 marker questions that come up for transition metals: catalysis mechanisms, color and colorimetry, complex shapes and isomerism, ligand substitution, thermodynamics, and redox calculations. Okay, so they're the main types that it knows, okay, from previous AQA papers. Obviously, if you're OCR, it'll give you it for OCR. And then what we can do is we can go, great, write a, where are we? I'll tell you what, typical 6 marker on complex ions and isomerism. So what it'll do is it'll use the past paper questions that already exist for your exam board and go, right, okay, I get the flavor of those, and it'll basically write as many as you like, okay, in the style of your exam board. So you'll never ever go short of questions, okay? So typical question here, describe the different shapes of complexes and show how they lead to different types of isomerism. Use examples of complexes of cobalt-2 and platinum-2, and you should draw the structures of the examples chosen. So it's picking specific transition metals that this exam board need to know. It will never ask you, like GPT and Gemini and stuff, it has no idea what's in the specification, even though you tell it. Okay, I've trained this from me, from the spec, from the book that I've written, from the exams. It's literally got access to all that information, and it will take all that information to utilize it to create you exam board specific questions, unlimited exam board specific questions. Okay. So now, how could I access the OCR A1? What makes Chemistry Coach better than ChatGPT, which is free? Okay, so let's talk about the differences just for a second here. So let me just take that share off screen, okay? In fact, let's try it, okay? Let's try it. Let's just do a live test, okay? So let's go to, let's see if I can log into Gemini. Does it know who I am already? Yeah, I am. I'm on the Pro version as well, okay? So I'm on the Pro version. And let's say I do AQA A-level chemistry. Which transition metals do I need to know the complexes for? Okay, fair question. So I know you're talking about OCR, Nana, but it's the AQA one I've got up. If you sign into Chemistry Coach, if you sign up to Chemistry Coach, then you can get access, obviously, to the OCR one. So I'm just going to set this going, okay? And like with this one, because it's AQA, I don't even have to say it, okay? I know I'm AQA, it knows I'm AQA. So what transition metal ions do I need to know the complexes for? Okay, so I basically asked it the same question. I have told Gemini that I am AQA specific, okay? So the difference with Chemistry Coach is that it's got access to all my experience as a tutor as well. That's why I call it an AI/tutor hybrid, okay? So Gemini, let's have a look. So FE, because I know them off the top of my head, all right? I know what's right and wrong. You can fact check me if you want, okay? So Fe2 plus, Fe3 plus, yes. Copper H2O, copper deep blue, CuCl4, maybe, okay? I don't think it is. I think that got taken out of the specification. So that third one there for copper, not included. Cobalt, I don't think so. Silver, and there's a summary table there. So basically what Gemini is telling you is like, these are all the ones you need to know, okay? But now I know that this and that silver one's kind of like, yeah, it's not even part of transition metals, okay? There's way more than this you need to know for AQA, okay? So if I go back to this one, okay, we have got iron, and it agrees, Fe2 plus, Fe3 plus, copper complexes. We've also got additional ones, aluminium 3, okay, so that's part of the reactions of ions in solution, okay, so the amphoteric Al3 plus, and the Mn2 plus MnO4, that's part of the catalysts, okay, and titrations, so they're the ones you need to know. In terms of aqueous solutions, okay, they're the different ones we need to know. So you do not need to know cobalt, okay. In fact, provide me a summary of all the complex and colors that I need to know for transition metals. We've kind of gone off piste a little bit here. We were talking about physical chemistry, I know, but in here as well, it will give you, hopefully, if I've asked it the right way, it'll give me the image, okay, the complete summary of what you need to know. Okay, it tells you even the origin of the colors there if you need to know that. There's your summary. So no cobalt needed. So you can't rely on Gemini to be accurate. And I spent a lot of time making sure that this AI behaves in the way that I would if I was tutoring you, okay? In terms of being exam board specific, it will never tell you that you need to know something that you don't. It will never leave something out that you don't need to know. So you're paying for the to pay into this is to pay for the experience, my experience, to know that it's 100% reliable. It will write unlimited questions for you and teach you anything that you want to be taught. Okay, and it will do it in such a way that it uses images and things like that, which GPT and Gemini do not. Okay, so it takes snapshots of the book, puts that in there when it's relevant if you need a diagram to kind of help you. So basically, what I've built here is a textbook that you can talk to. All right, and it's got all my insight and experience and stuff like that as well. It'll even perform analyses on exam papers for you. Okay, so for example, let's say you are revising, okay, and you've done a past paper. Let's say, hey, I want to practice a paper 1, right? I've done a paper 1, I've just sat down and had a go at it, and you've marked it, and you go, okay, well, what do I do now? Like, what do I do now? You need to use those exam papers to inform your revision. Like, what do I suck at? Well, those are the things that I need to work on. So let's say I just did paper 1, 2018. I lost the most marks on, and I have no idea what these questions are, I haven't looked, on questions 3 and 7. Put together an action plan. No. I'll tell you what, come on, Rich. Let's say, okay, I have 2 hours to do some work on these. First, walk me through the questions, then set me some work to do so I can improve. Now, what I can do is, let's just copy this. Let's just put it into Gemini. I have no idea what Gemini is going to do. This is live. This is like, who knows what's going to happen. Okay, you still here, Nana? Just kind of answering your question. So losing marks on it is quite common. Okay, fair enough. Okay, so question tested. Thermodynamics, question 7, analysis, metal, aqua, ions, your 2-hour action plan. Step 1, 20 minutes, master the key equations and conversions, okay? Literally what I was saying, delta H's, okay? You need to know those delta H's, practice entropy calculations. So ready to start? Let's go, okay? So let's go thermodynamics first, okay? Let's see how we go. So with this one, okay, fair enough. It knows it's thermodynamics. Acids and bases. So it says it's acids and bases, okay? But it's not. It's absolutely not. Question 7 is not acids, bases, and pH from question from that paper. It's absolutely metal, aqua, ions, okay? So this is using a database that I've given it, and it knows exactly what the questions are and how to answer them. So here we go. So revision here, master the key questions, what are the feasibility rules for delta G, what are the different combinations, and it gives you some practice calculations to do and more advanced problems as well. Okay, so that's what it'll do for you. Gemini, what's it doing down here? Your 2-hour rapid improvement plan. Basically, it's telling you to do stuff on buffers, and it's nothing to do with buffers, that question. But has it set questions? No. Has it given you a study plan? No. Okay, so what this will do is, obviously, every time you do this, it remembers, okay? So at some point, if you're using it throughout the year, at some point you can go, right, you know, based on our chat history, like, what are my weakest topics? Where do I need to focus? Maybe you give, every time you do a test or an exam, you can give it those results, and it will remember those results and actually go at the end of the year, right, okay, based on the previous Unit 1 papers that you've done, or paper 1s that you've done, then it will tell you, okay, these are your like priority areas, and not just priority areas where you've lost marks, but it will also take into account how common those questions come up in the exams. So it will balance, like, okay, if you really suck at this thing over here, but it rarely comes up in the exams, it's going to give you a low priority. If you suck at this thing over here and it comes up every year, it's going to make it a high priority for you, okay? That was a bit long-winded, but does that answer your question, Nana? Does that answer your question? Okay, no worries. Okay, so it's a lot different, okay? And this is what I'm trying to get across to students. So, other requests. We've talked about, I'll tell you what we haven't talked about. I remember somebody, since this is brought up buffers anyway, Gemini talking BS about buffers and stuff like that. Let's go to acids and bases, okay? Now, buffers, okay, that's weak acids, pH curves. Where's buffers? Okay. Now, when it comes to buffers, super important, what you need to do is make sure you understand how one works, okay? Now, the fundamental principle behind buffers, how buffers work, is what? Whose principle is the underlying kind of engine, if you like, behind buffers, ladies and gents? Any takers whatsoever? Yeah, it is. Thank you very much. Le Chatelier's. Le Chatelier's is super important, okay? So any ASs that might be watching this on socials, Le Chatelier's comes back with a vengeance in year 2, okay, year 13. It's involved in organic chemistry when you get to like, acids, okay, and hydrolysis and things like that. But also, really importantly, weak acids and buffers, okay? So being able to go, okay, if you add an acid, it's going to move this way to oppose the change. If you add a base, it's going to move this way to oppose the change, okay? So again, things you need to know. What is a buffer? You need to be able to, you need to know how to explain how a buffer system works, okay? When you add A, it shifts this way to oppose the change. When you add B, and it's maintaining that H plus concentration. Other things you need to know are obviously the equation, okay, for Ka in terms of those. Okay, there we go. So your Ka expression. And then, of course, we get onto things you need to be able to do. There's very little you need to know here. It's just practice, practice, practice with the calculations. Now, with the calculations, there are 3 different types of buffer questions in the exams with a specific technique to each. It looks like every buffer question you get is completely different. It couldn't be further from the truth. They look different, but they're not, okay? So I'm just going to list for you the 3 different types of buffers, buffer calculation that you get, okay? So let's not do red, it's very angry. Okay, so buffer question types, or flavors I call them. So number 1 is where you make a buffer using the weak acid and the salt of the weak acid. Now, to me, that's basically you're making a buffer. The question will say a buffer is produced, or a student was making a buffer, or words like to that effect. But they're making it using the raw ingredients for a buffer. There's no reaction. Okay, they'll give you the amounts of weak acid and the amount of salt and the volume and everything like that, and all you need to do is calculate the pH, okay? Or it could be that they've given you the pH, you need to calculate how much salt was put in there to create it, okay? So, you need to be able to obviously rearrange that Ka expression. But with these are the simplest, okay? Because there's no reaction, you're just using numbers and rearranging that Ka expression to find something you want, whether it's pH, whether it's the concentration, therefore the mass of salt, anything like that. So they're nice and straightforward. Weak acid, Wa, okay? So Wa equals weak acid. And I'm going to be using this as well, strong base. So the second type is again where we are making a buffer. So ask yourself when you read the question, are we making a buffer here? So we make a buffer this time by reaction, okay? So what that is where you take a weak acid and react it with a strong base. And what that gives you is the salt of the weak acid and water, okay? So we are creating a buffer, but this time we're using the reaction between the weak acid and a strong base to make the salt of a weak acid, okay? Now, word to the wise, whenever you get these, okay, you need to use this equation first. This is what you should be looking at first. So you take this weak acid, this is always going to be in excess, okay? And this is always going to be limiting any question you come across. The reason being, if this is limiting, all of this is going to get used up in the reaction. You're going to have some of this left over and you will have made the salt of the weak acid. There'll be no strong base left. That's a buffer solution, isn't it? A weak acid and the salt of the weak acid. However, if it was the other way around, okay, so if this was limiting and this was in excess, this would all be used up and then you just end up with a solution of strong base and the salt of the weak acid, which is not a buffer solution, okay? So in any question they give you, they will always have the weak acid in excess. So you'll need to use calculations, okay, using X and Y to find the amount of salt that you've made, okay? You need to find out how much weak acid remains after the reaction. That's how much weak acid's in your buffer. And then how much salt did you make? That's how much salt is in your buffer. And then you can use these two to actually find the pH or whatever it is they're asking you to do. Okay, so that's the second type there. And, you know, as you saw before, there are videos. Okay, so that's not what I wanted. In the notes, okay, you will get, okay, QR codes, so you can use your phone, you can click on them as well. That'll take you to the video where I go through all these three different types and walk you through examples, and there's a downloadable worksheet, etc., etc. Okay. Equally, you can just go into how do I do buffer calculations? Very simple question I'm asking it there. And it'll talk you through it, but it should also provide you with my video on it, okay? Let's stick to chemistry. Oh, behave yourself, okay? So, how do I answer buffer calculation questions? It probably weirded it out because we were talking about lattice enthalpy a second ago, and now it's like, what? Okay, so it tells you about the key foundations, what you need to know. There it is, buffer calculations, the three different types. There you go. So it's going through exactly what I'm telling you right now, okay? And that video absolutely does that for you when you get access to this, okay? So what is the third type? Well, the third type, number 3, is where an acid or base is added to an existing buffer. Okay, so in the question, what you're looking for is the context here. Okay, a student created a buffer using X and Y. They then added 2 centimeter cubed of 1 molar HCl. Okay, which is actually quite a lot, but it's that sort of thing. Okay, now with these acid, when you've got this third type of question, okay, this is what you need to write out in terms of an equation for this type. But with your third type, it's about, let's say you're using ethanoic acid, write this out, okay? So obviously we've got, this represents the weak acid, this represents the salt, and of course these are our hydrogen ions on the right here. So for example, if I've got, in the buffer solution, we know there's 10 moles of this and 8 moles of this. And therefore 8 moles of that. No, that doesn't track. But anyway, basically, if you add H+, so if you're adding an acid to this solution, which way is it going to shift? Now, Le Chatelier's in play here. Answers in the chat, please, folks. If I add an acid, i.e. H+, to this equilibrium in a buffer, which way is it going to shift? Left or right is the answer, I suppose. Shifts right. It is not shifts right. okay? It is left. Good, okay? So the reason is if I increase this concentration of hydrogen ions by adding an acid, it's going to shift left to bring that back down and oppose the change. So what's going to happen when I add an acid, however many moles of acid this is, okay, it gets added to this side, but then subtracted from this side, okay? Because it's shifting left, we're using up the products on the right, we're using those up to shift to the left and make the reactants on the left. The opposite is true, okay? If I add sodium hydroxide, that's going to lower the hydrogen ion concentration. They're going to neutralize, okay? And it's going to shift to the right, okay? And this time, that's going to go down by that amount, and this is going to go up by that amount. So we can measure how much the relative amounts of acid and base are changing. So those are the three main types, and in a real nutshell, like how to deal with them, okay? But as I say, that video goes through all three. I'm pretty sure in my TikToks, there's some old TikToks in there where I've gone buffer calculation hack 1, buffer calculation hack 2, and buffer calculation hack 3. So they're in there if you want to go and find those, all right? So that's my advice for buffers. Once you've got an ion, in fact, in the course, I've got a worksheet that's got every buffer calculation ever asked by basically all the exam boards. Okay, so if you can work through those and do those, then you've got absolutely nothing to fear. Okay, it's like I said, this is definitely things that you need to be able to do, and that is tackle these problem-solving buffer calculation questions. Okay, so make sure you've made a note of those, take a screenshot, do what you need to do, and we can. I want you to go away and practice those if you've covered them already. Okay, definitely practice those if you've covered them already. So. What next? What was the other request here? Oh, it was electrochemistry. Okay. Top tip for electrochemistry, and this is the one I always kind of give out, is, I should say, at any point when you're signed into Chemistry Coach, you can click this button at the bottom and it'll just take you to the AI. So if you're reading the notes and you're like, oh, okay, like I got a question about this, just hit that and, it will take you to Chemistry Coach, but obviously I'm not logged in. So, okay, so let's go back to physical chemistry. Whoop. Okay. This is what I want you to write down. Okay. So obviously we've got our standard hydrogen electrode. That's what's used to measure all the other electrode potentials against it. But when, and it's more likely that you get this in an exam, when you're combining two random half cells. Now I've got aluminium, so I've got Al electrode and Al3+, that should say Al, my apologies, and the copper one on the right hand side. Now, there are a couple of mantras, a couple of rules, okay, that I want you to kind of recite when you're looking into redox, okay, in electrochemistry. The first is lone. Okay, so when you've got two half cells hooked up like this, the general convention is that the half cell on the left is where oxidation occurs. It's the anode, which is the negative electrode. And of course, RRCP, yeah, that's the opposite. But if you remember lone, left, oxidation is happening there. It's the anode and it's the negative electrode, okay? So at that point, you know, okay, that this is also, let me just kind of reset this because my pen's not working again. So we got lone, but this is also the most negative half cell, okay? So not only is it a negative electrode, it's also the most negative half cell as well. So this must be most positive, okay? So that convention there, you can absolutely fall back on because you know when you get stuck into these electrochem questions that you can tie yourself in knots a little bit with it, okay? So that's the first mantra. When you've got two half cells, left oxidation, anode, it's the negative one, and little Brucey bonus, it's also the most negative half cell. And we can guarantee then that the electrons are going from this side, because oxidation, they're losing electrons, they're building up in this side over here, and they're being used up on this side over here. So the electrons flow from left to right. That's why we always get a positive value on our voltmeter. Okay, that is why, because the convention says that the cell where oxidation is happening is on the left. Okay, does loan make sense to you guys? Let me know in the chat. Brilliant. You can always use that. Okay, it's always something to fall back on. Stuff like oil rig, I still just fall back on that. Whenever I'm doing questions on redox, I'm like, okay, oxidation is loss, reduction is gain. So the other thing, okay, just to kind of follow on from that, is when we've got the standard hydrogen electrode, the She, okay, this is the only exception to that rule. Okay, of course, chemistry is full of rules and there are exceptions. The standard hydrogen electrode is always placed on the left-hand side, okay? This reason, when we've got all these values, let's say in our electrochemical series, like this one, for example, okay, we've got negative ones and we've got positive ones. And the reason is because we've always got the She on the left-hand side. So when we've got the She on the left-hand side and we do it with copper, because this half cell is being oxidized, okay, the electrons, like we saw before, are going this way. But then when we hook it up to something that is unable to oxidize hydrogen, because it's on the left-hand side, that's when we get these negative values because the electrons are flowing the other way. Okay, under normal circumstances, we'd have put this one on the left-hand side. But because it's the She and the rule is She lives on the left-hand side, okay, then that's why we get negative numbers in the voltmeter because the electrons are going the wrong way, essentially. Okay, so just bear that in mind. Now, the other thing I want to tell you about electrochemistry, which can help you, is that when you get your electrochemical series, it's very often the case that you get the most negative on top, okay? In which case, you can rely on the fact, well, you can always rely on the fact that all these down the right-hand side here, these are all reducing agents because they are the oxidized state of that species. So Li is the oxidized state of lithium. Li is the, come on, Rich, is the reduced state. My apologies. Okay, so they're the reducing agents. They will get oxidized themselves. Okay, so on the right hand side, they're all reducing agents. Okay, they're in the lowest oxidation state they can be, and then they get oxidized to their most positive state. Okay, so they're all reducing agents on the right. The strongest one is top right. Okay, so in this list, it's lithium. Flip side, all of these are oxidizing agents. They are the oxidized versions of these species, and therefore they can be reduced. So that means if they're being reduced, they're acting as oxidizing agents. They must be oxidizing something else. Your strongest oxidizing agent is always found bottom left. Okay, now that of course relies on the fact that the most negatives up here. Obviously, it flips if the table's upside down, and sometimes they do that, and it's highly annoying because, like, why are you messing with that convention? Okay, why are you messing with that convention? So knowing where these are, and actually this then feeds into the third thing I want to show you. This is what's known as the anti-clockwise rule. So let's say we pick two things at random. Let's say we pick calcium and copper. Okay, I'm picking these two half cells. I'm going to bung them together. What happens? Okay, what happens at each of these half cells when you put these two together? Well, two ways of doing it. One, you can remember lone. Okay, lone is the one that gets oxidized and it's the most negative. It's the negative half cell, it's the most negative thing. So this is going to get oxidized. So calcium must be oxidized to Ca2+. Okay, now of course we've got RrCp on the other side. If this is being oxidized, this half cell, the copper must be being reduced. Okay, so we can predict what's going to happen in each half cell when we put them together using lone. And that then gives us our kind of third rule is the anti-clockwise rule, which is where if you have the most negative on top, okay, these arrows you'll see flow anti-clockwise. Okay, like that or that. I know, depending on how you look at it, I don't know whether you're mirrored on the screen or not, but that's the anti-clockwise rule, and it predicts what's going to happen in this reaction. Okay, so those are the three things: lone, knowing your where your reducing agents are and which one your strongest is, and of course the same for oxidizing. And then you've got your anti-clockwise rule, which can predict what's going to happen when you put any two half cells together. Now, they will ask you, why? Why is it that calcium is able to reduce Cu2+? Why is it that Cu2+ is able to oxidize calcium? You know, so they could ask you, why is this reaction going to happen? You can't say, oh, because of alone, or because of the anti-clockwise rule. You can't say that. Okay, those are tools to help you get to the answer. When they ask you why, you have to reference the electrode potentials. Why does calcium reduce copper? Because calcium half cell is more negative than the copper half cell. That's the answer. Okay. You could even say, why does calcium reduce copper 2+? Well, because the copper 2+ half cell is more positive than the calcium half cell. You could say the inverse. Okay. In that respect, that means the copper is going to get reduced because it's the most positive, and the most negative is going to get oxidized. Okay. So you basically, you don't even have to think about it. It's just a statement of fact. Just say what you see. Okay. So they helpful, guys? Have we got those down? Anybody want me to repeat anything? Brilliant. So what's next, folks? I've got another 30 minutes, okay? 30 minutes, something like that. So, if anybody's watching on YouTube, they said hi, I say hi back, by the way. Anything else that you'd like me to maybe cover, go over, anything you want me to test Chemistry Coach with to see what it can do for you? I want you guys to kind of really help me kind of put Chemistry Coach through its paces, just to see how helpful it can actually be in creating things for you. So while you guys have a think of that, let me show you what else we can do. And it is this. So let me just reset it. Okay. So I have a test on, what are we having a test on? Let's say it is, what was I going to use? Oh, I was going to electrochemistry. In 2 days, write me a 40 mark mock exam that tests me on all the major principles in that topic. So the more specific you get, the more specific you are with your questions, okay, then the more specific the reply is going to give you back. All right. So you could just say, oh, write me some questions on electrochemistry. Well, actually, you know, in 2 days, you know, it might even pick up on that and say, well, okay, here's a 40 mark mock exam, and then we'll go from there. So let's see what it does for you. So again, you don't have to go looking for resources, and you can rely on this to write questions for you because it knows all of the past paper questions. Okay, all of the past paper questions. So data sheet. You may need the following standard electrode potentials. Fair enough. I mean, it's give us a data sheet to work with. Question 1, electrode potentials and EMF. Predicting redox reactions. Commercial applications. So this is where you need to know about hydrogen fuel cell, combustion engines versus standard fuel cells and stuff like that. AQA only. Electrochemical calculations, calculating EMF. An extended response question. Okay. Based on half cells, okay, end of paper. So it has given you the answers as well, okay. So what it'll say at the end is, once you've attempted it, let me know how you got on. I can provide detailed feedback in areas where you need more practice. Remember, it's about understanding electron flow and using electron potentials to predict what will happen. You've got this. So it's really supportive. You know, I've made it so it's super supportive. Maybe it's a little bit kind of much sometimes, but at least it's friendly, right? So if you tell it how you got on, you can tell it like, okay, I didn't get the answers to question 1.2, 2.1, so on and so forth. It will then teach you. It'll explain why. And that's the benefit of it as well, in that when you're using a mark scheme, and mark schemes are useful for the knowledge questions, for the explain questions, not for the calculation questions. They are a nightmare. They just kind of blurt the numbers on the page. You're like, well, yeah, that's great. I didn't get the right answer, but like why did you use the numbers that you've used? Where did you even get those numbers from? So it can absolutely do that. So if you've got that question, big old 6-mark calculation question, let's say on time of flight, or it's a big old titration question calculation, then you can say, oh, well, this question in paper 1 2017 3.2, like explain the calculation to me, and it will absolutely do that for you. Okay, so that's what it can do. So I still not getting any requests in. Like, no one's talking to me today. Oh, Mira, I do apologize. Does the electrode get thinner? I've just seen these. Okay, so back to electrodes. Yes, it does. Okay, so let's go back to this one. So in terms of the electrodes, apologies, I missed this because it was hidden, but in terms of the ones that are going to lose mass, the one on the left is going to lose mass. Okay, the reason is because the solid metal is being turned into an ion. So the electrodes will lose mass, or the electrode, the negative, okay, anode, is going to lose mass over time, apart from if it's a platinum one, okay, because if it's got 2 ions in solution, for example, because the platinum's not being used up. But if it's the metal electrode of that metal half cell, then yes, it'll lose mass. This will gain mass as copper binds to it when it is produced. Okay. Could I prove it with an E-cell equation? Well, yes. I mean, absolutely. This is your explanation. Okay, so you can give the overall equation for this if we balance it. So that, I think, is probably going to be 3Cu2 plus 2Al goes to 3Cu and 2Al3 plus. So you can say here that this is AQ going to a solid, proving that that's going to gain mass. This is going from a solid to an AQ, so proving that that is losing mass. Does that answer your question there? On can I prove it with an E-cell value / equation? So in order to, if they asked you like which of these electrodes is going to lose mass, well, you can say, okay, based on this is the most negative electrode, therefore oxidation's happening here, therefore the metal's being turned into a metal ion, so therefore the the electrode is going to lose mass as the cell continues to work. Okay, so it's again, just going through the motion. Always with electrochemistry, start at the top. Okay, what's happening in each of the half cells, and that will end up explaining, if you work your way down through loan and stuff, it will end up explaining the answer to you. Okay, and that's what you need to put in the exam paper. All right. So, any other requests or chat, guys? If not, I'm gonna just leave you guys to it. Essentially, what other advice would I give for A-level students right now? And that is, as I mentioned before, any tips on remembering inorganic equations, especially stuff for Group 2, Group 7, and Period 3. So that sounds like ASAQA to me. So Group 2, Group 7, Period 3, okay, they are a pain. You're absolutely right there. That firmly lands under stuff I need to know. Okay, so there are typical equations. In fact, I haven't got the AS one up actually, but you can ask again, Chemistry Coach, what are the equations I need to know? I've actually got inbuilt flashcards in there as well. Hi on YouTube. I've actually got inbuilt flashcards in the Chemistry Coach as well for those. And I'm sorry, and I hate to say it, and I know you're not going to want to hear it, and I think you know what I'm going to say, spaced repetition. That's it. Okay, I've just been analyzing some AQA-AS papers today actually, and they ask about like sulfur scrubbing using calcium, and they use they've asked about magnesium and how it's used to extract titanium, like those equations there. For Group 7, okay, know your redox trends. They love a redox equation question with Group 7, okay, displacement reactions as they were between the halogens and halides. Like strength of oxidizing and reducing power, which can be explained by atomic structure, okay? But I think I know what you're on about, Group 7. The reducing power linked with their reactions with conc H2SO4. I think everybody, no, I don't think OCR have to do those, but they suck. They really suck, okay? My advice is they very rarely ask about the equations. I would spend some time trying to learn them. There is a pattern, and there's actually a page in the AS chemistry coach notes, okay, in the AS book. There's just a page of them, okay, and learn them. But the most important things you should learn, because the things that I've analysed, the exam papers, and the thing they ask most about are the observations. You're like, oh, what's the halide ion if we react it with conch sulfuric acid and you get purple fumes and the smell of rotten eggs? It's going to be iodide, okay? So learn those. I would say if you're going to do anything with those, learn the observations for group 7 halides with sulfuric acid. And of course, it all tracks with the fact that as you go down the group, the halides, the negative ions of the halogens, they become stronger reducing agents as you go down because they more easily lose an electron, extra shielding, distance from nucleus, all that. And they're able to, an iodide is able to reduce sulfur multiple times. So you get from sulfuric acid to sulfur dioxide, you get sulfur and you get H2S. Okay, so learn the observations, okay, for both bromide and iodide. Okay, chloride doesn't undergo a redox reaction. Okay, it's not a strong enough reducing agent, but bromide and iodide are. Okay, now period 3 stuff, again, it's all about bonding. Okay, trend in period 3 for AS, it's just a trend in bonding, so it's all about knowing your IMFs, giant covalent, metallic. Okay, for period 3 oxides, parrot fashion learning, there are overarching themes that you can work with. Okay, so period 3 in their oxides, which AQA only, not spoiler alert, but alert, I am talking about AQA only here, is that the overarching themes are, okay, so your metal oxides are basic. Okay, so you know they're going to produce the hydroxides when they react with water. Your non-metal oxides are acidic, so they're going to form acids when they react with water. So there's overarching things that you can apply there, okay? But you do have to know some real detail, like even like the shapes of the molecules of the acids that are produced when P4O10 reacts with water, when carbon dioxide reacts with water, and when nitrogen oxide reacts with water. Okay, so there's a lot of detail there, and again, firmly under the column of shit I need to know, right? As opposed to shit I need to be able to do. Okay, so stuff I need to know, definitely recalling those equations. But again, after analyzing the papers, you can ask it like, you know, what typical questions come up on period 3 oxides. Okay, so let's just do that. Let's just test that theory, shall we? Okay, so I'm now working on period 3 oxides and period 3 oxides. Okay, list all of the equations that I need to know. Okay, so you can make your own flashcards, although, you know, if you ask it for the flashcards, it will give those as well. But again, if you ask GPT to do this for you, if you ask Gemini to do this for you, it has no idea like what equations you need to know, but this is all based on my notes. This is all based on the specification. It's all based on past exams. Okay, so here we go. Formation of the oxides and water, neutralizations of them. So they give you examples of those. Okay, acid dissociation equations. So how the acids form acids in solution. And then there's some key patterns to remember as well. So it's really good at not only condensing information for you, but for like just giving you the zoomed out, like this is basically what you need to know. Okay. So those are the things. Oh, I forgot about sulfur dioxide, of course, in water, which you need to know. Okay. So, you know, again, at any point, just say you can, if you want to know the notes, okay, say, can you link to these notes? So you don't have to go looking for it. If you can't be bothered kind of flicking through the book, it will just give you the link to them. Okay. So as far as the videos are concerned in Chemistry Coach, I've done videos on skills, things you need to be able to do. You're not going to find a video on what equations do you need to know for period 3 oxides, because what's the point of that? Okay. Yeah, you can find videos on YouTube, but it's kind of like, why would I watch a video on that? That is just learn those equations. That's just what I need to do. You don't need a video for that, okay? You just need to learn them. So study resources, period 3 elements and oxides notes. There we go. Period 3 elements, oxides, flashcards. I've housed those in QuizGecko. Elements and oxides notes. So they'll pop up as a download, okay? Where are we? Period 3 elements and oxides exam questions, again, will pop up as a question pack for you, okay? So if you want actual questions, that's fair enough, but equally, you've got as much practice as you like through Chemistry Coach to write as many questions as you like, and you can guarantee that they are specific, that they won't miss anything out. You know, you could even ask it to write multiple choice questions for you. So write me 30 multiple choice questions on period 3 oxides. So literally, like, you don't even have to look for stuff anymore, okay? It literally just makes it for you. So I'd like you actually in the comments, so whether that's on socials, whether it's on in the webinar itself, there you go, like, not even breaking a sweat, okay? So you've got all the practice that you would like. And the best thing is that, let's say it's like, oh, question 17, I have no idea why that's the right answer. Explain it to me. It will. Okay, not like a textbook, not like you know, the kind of question packs you get online where they just give you the answers like A, B, C, D, whatever. Okay, I know it's giving you the answers here and basically not explaining it, but if you want to ask it, you know, then you can ask it. So why is it C for question 30? Don't understand. Okay, so then it will explain it to you. Okay, like I said, it's just like having literally a personal tutor that you're talking to all of the time. So here we go. You just need to look at, it's a fact that you need to remember. Okay, that's what it's saying. Okay, so why are they insoluble? Oh, well, because that's just a fact. They are insoluble. That's why there's no reaction. Okay. So, and you know what, I've not done this for ages. Like, if you press this little button down here, this kind of waveform button, okay, let's see how we go. It's not going to do anything. So it will talk to you. I mean, it's not like, it's a little robotic, but you know, nothing's perfect. That leads me on to actually, like, what is it the Chemistry Coach can't do? Well, actually what it can't do is draw pictures. So if you ask it, like, draw the mechanism for the reaction between prop-1-ene and HBr, it's not going to be able to do that. It's got a picture which it will show you the generic mechanism for that, but it can't draw pictures. But then GPT won't do that. Google won't, Gemini won't do that, okay? AI's not there yet. That's why it's not in here, okay? It's because that's a limitation of AI across the board. Unless you're generating images, and you need to tell it what to do then, okay? Not ask it for an image. So it can't do that. It can't draw graphs and stuff like that. So when you do get questions, yes, they are text-based, but when you're getting explanations, there will be pictures when they're relevant, and there will be videos when they're relevant. There will be resources when they're relevant, okay? The voice is rubbish anyway, so I'm just going to ignore that. So any other questions for me, guys, please put them in the chat. Then if not, then I will bid you guys adieu and thank you for joining me. And hopefully you've picked up just a few hints and tips for your A-level chemistry. We've talked mainly about physical chemistry. Let's make another day. Let's talk about organic chemistry at another time as well. Okay, but in the meantime, okay, so this is what I would like you to do. Okay, so if you're interested, which I hope you are, then this link, okay, that I'm about to post, I'll just put it in all the comments. Oops. One there. I'm going to put it here. And I'm also going to put it here. So that link there, I know it's like a weird link, but it's basically just a kind of one page. You put your email in, you will get sent an email with links to AQA, OCR, and WJEC. You just pick your exam board and you can download the notes, okay? It's all the AS and A-level notes, so it's basically the entire book, okay? And at any point, you can just click the button at the bottom and it'll take you to Chemistry Coach, okay? But you need to be a member, obviously, to use the thing. But luckily in that email, you will get a discount code as well. Now, in Chemistry Coach, if you are a member, okay, yes, you get access to these notes, okay? I want to make these notes public, okay, because I think they're everything you need to know and nothing you don't. It's all very, very concise. But on top of that, when you join Chemistry Coach, obviously you get your own personal 24-hour tutor that remembers what you've been doing, remembers your learning style, okay, and will teach you in the way that you ask it to teach you, all right? Based on the exam board specification and previous exams and all my advice and knowledge all built into it at the same time. And that's unlimited use. I mean, obviously, kind of what we say is, you know, the kind of standard thing to say is, you know, limits apply. You know, if you're smashing it every day, then, you know, the other things you will get with Chemistry Coach are you get my Organic Pathfinder. You'll get all the practical guide notes as well. Okay, so basically going through all the required practicals and the calculation pathways that come along with them, and of course all the errors and like stuff like that you need to know for the practicals. Again, Chemistry Coach will absolutely write practical questions for you and teach you through all the required practicals you need to know. If you ask Gemini or ChatGPT, it will not know. It will not know, okay? So that's why Chemistry Coach is so special, because it's me inside there, okay? It's kind of like all my knowledge, all my experience, all the notes, all my explanations, and all the exams. Basically, it's more of an expert than I ever will be. Because if you ask me what's question 2.2 in 2017 paper 2, I have no idea. But Chemistry Coach does, you know, not off the top of my head anyway. Shouldn't take very long for that email to come through once you put your email address in. So if you've got that link in the chat, please click it. You can download those notes for free, just to give you a reminder. In terms of, let's go to chemistrycoach.co.uk. Okay, so in fact, let's not go there. Let's go here. Okay, so when you go to Chemistry Coach, this is what you'll come across. This is my little man. Okay, this where are we? I should be sharing my screen again. This is like my little dude. Okay, so he's there to help you. This is the Chemistry Coach. Like I said, it's an AI tutor hybrid. There's a video on there you can watch and how it works, what it does for you, what it will actually do, what's included, and you know, this is important. When you get personalized help, you get much better, okay? But of course, you know, Chemistry Coach is not going to kind of tell you when to do work. It's not going to make appointments with you like a tutor would and stuff like that. Of course it doesn't. It just sits there waiting for you to kind of come and do some work, okay? But if you're motivated, this will be you. Okay, right up here, you're going to outperform everybody else because you've got personalized one-to-one help, and you know there's always a fail-safe. There's always me. Okay, so you can always come to one of the lives that I do, or drop me a message on the website or whatever. So you know you can absolutely kind of get help from me as well. So like I said, my name's Rich. I'm the developer behind the Chemistry Tutor and a developer behind Chemistry Coach, your expert AI kind of personal tutor. I say kind of personal tutor, it absolutely is a personal tutor, okay? So right now, as I mentioned, you can get this for AQA, OCR, OCRA, and WJEC. So if you know anyone in Wales where, you know, resources are scarce, because I'm in Wrexham in North Wales, then please let them know, okay? Because there's very little out there for WJEC, okay? So fantastic. Okay, so you've all got the links, and we've all learned something today. I've learned, every time I open up Chemistry Coach, I get it to do something different for me. So yeah, if you want to register, then please go ahead. Those of you that signed up to get the notes, you'll also get a discount code in the email. And those of you that have been in here with me today in the actual live webinar, not online on TikTok or YouTube or anywhere like that, the ones that are in here, I'm going to put your names into a hat, and before the end of the day, I'll be emailing one of you with a free subscription or free membership to Chemistry Coach to thank you for kind of joining me. Okay, so the other day, I'm sure she won't mind me saying, Alicia, okay, from the AS, I sent her an email and she was very, very pleased, which I'm very pleased to say, and hopefully she's kind of utilizing Chemistry Coach now. So yeah, I promise you it's going to be completely at random. All the names that are registered for this live, I'm just going to put into a hat. If you haven't received an email, if you wake up tomorrow morning there isn't an email there, then it's been done. Okay, so thank you so much for joining me. Please share the love. Okay, I'm kind of struggling at the moment getting word out about Chemistry Coach and my channel on TikTok and stuff like that. So yeah, do me a solid. Whenever you see me pop up in your feed, if you are on TikTok, then just drop us a like, drop us a bookmark. Maybe forward it to your mates or something like that. Because yes, I'm a full-time working tutor in college, but I'm also running this and developing this to help students and make tutoring affordable. That's what I'm trying to do, okay? One-to-one tuition, like for expert tuition, is through the roof. And I do a bit of that, but this is what I'm trying to do, is bring it to the masses to help more students access the help that they need when they need it. And that's what Chemistry Coach is doing. So if you're interested, please sign up. If you're not, then don't. Legend. Thank you very much. I'll take that. Legend in my own lunchtime, as they say. All right, guys. So I'll see you around on socials. Maybe I'll be doing some more of these on the run-up to the exams, talk about exam technique and exam training and exam strategies and all that sort of jazz. So please do keep an eye out, okay? Follow me on socials. You'll get first word then as to what I'm doing and when. Probably around Easter will be the next thing, okay? But don't forget, A-level students, revision starts now. You've completed a unit. Do a paper, okay? Thank you so much, guys. I'll see you around.